Hi guys, in this video we're going to be going over Newton's law of universal gravitation, definition and formula, and then we're just going to go over a couple of examples because I haven't done that yet. So you already should be familiar with Newton's law of universal gravitation, as explained in a previous video, but we'll just go through it again. It says that each body in the universe attracts every other body with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. The formula for this is given below, and there's the constant g that's there. So it's quite straightforward. I'm just going to do some examples here. There's not too much explanation in this video. Cool. So this question has been adapted from the December exam for 2015. So it's quite straightforward actually, these questions. You should be very lucky if you get these type of questions in your exam. They usually count for about 4 or 5 marks, and it's just basically writing a formula and putting in values. So it says here, a hypothetical planet A has mass 7.5 times 10 to the minus 20 kgs and radius of 550 kilometers. Calculate the gravitational force, weight, that a planet A exerts on an 85 kg rock that is on this planet. So just one thing you should remember, the only way you can get caught out here is if you don't change units. Masses should be in kgs, and distances, so masses should be in kgs, and distances should be in meters, right? So that's the only thing you have to remember, and then after this just plug in the formula. So we say F is equal to G m1 m2 over r squared. Don't forget the radius is squared, distance is squared. Put in the values. We have 6.67 times 10 to the minus 11. The mass of the planet is 7.5 times 10 to the 20. Mass of the rock is 85 kilograms. And the distance is 550 times 10 to the 3, or times 1000 to convert to meters. And don't forget the squared. That's where you often get caught out, and that can cause it for you in the test exam. And then substitute, plug into the calculator, and you get an answer of 14,07 newtons. And that's it. You get 4 or 5 marks just for that. Make sure you write the formula and substitute correctly, and make the change over here, changing units. That's pretty much it. But more often than getting tested like this in an exam, even though this question is adapted from an exam, you get tested in multiple choice. And what you can expect in multiple choice is more along the lines of the next question that we have here. Usually we're given a multiple choice answer, so it'll be one of 4 answers, and so it'll be something along the lines of this. Say, body X and body Y are separated by a distance d. The gravitational force exerted by X on Y is F. Determine the gravitational force if the distance between the bodies is increased to 4d. And then you'll be given a bunch of options. So we know that F is equal to G m1 m2 all over r squared. In this case, in the original, before it's changed, F is actually equal to G m1 m2 all over d squared. Right. So now we have a new gravitational force applied. So we have F nu is equal to G m1 m2 over the distance has increased to 4d, and that's all squared. Complete the bracket, and we get 16d squared. Now if you can rewrite this to make it a bit more clear, you're going to get 1 over 16 G m1 m2 over d squared. It's the same thing, just some basic algebra. But this here we can recognize is simply your F. This is therefore equal to 1 over 16 F. And this would be your multiple choice answer, F nu. So usually it's about 2 marks. You're going to get something like this. The key is to remember to put this 4d here in the bracket and square the whole bracket to get 1 over 16. Sometimes if you get that and you end up just getting 1/4 and that's the incorrect answer, but it'll be given to you in multiple choice, so you might think you have the right answer. So that's just a quick example of what you can expect for Newton's law of gravitational force in a test or exam. Right, that's it. Thanks, guys.